Okay, so this is a question on the calorimetry, and let's try to understand what this means. And this is about the coffee cup calorimeter. So what's that really they're trying to say? So you have a coffee cup which is made out of styrofoam, which is a well insulated material. Okay, so I mean this is, let's say you have so this is a foam cup. So what they're trying to say is the heat cannot escape from here. So whatever is happening, the heat is retained within this to contain whatever it is. They use it for changing the temperature. So that's a good thing, that it is an essentially thermally insulated system. That's a more practical word, and in the thermodynamic description, Q and the system inside, the Q value is 0. Okay, so then now this is filled with the water, and water has an intrinsic property called heat capacity or specific heat. And as you may all remember, this one is 1 calorie, 1 gram, 1 degree C. Okay, it takes 1 calorie heat to heat 1 grams of water, right? And by 1 degree C. And then later, the people find out the calorie is just nothing but 4.184 joule, 1 gram, 1 degree C. Okay, so that's the meaning of the heat capacity. How much heat do you need for a system of certain mass by a certain degree C? This is the heat that you need to raise up the temperature of the water for this, and that's a 1 calorie, which is the intrinsic property of the material. And the water happens to be a 1 calorie. So what is, so the A, let's read the problem. What is energy changes in joule, okay, when temperature of the water is increased to 27.4 degrees C, which is used to be this, right? So the Q, which is a mass of water, multiplied by C, water, multiplied by temperature change, delta T. And the mass here is 100.0 gram. Okay, that assuming the density is 1. Okay, density of water is 1 gram per milliliter. Okay, so that's another quantity that we use. And then we are using 1 gram, 1 degree C, 4.184 joule. Okay, that's a heat capacity, specific heat for water. And then what's my delta T, which is a final temperature 27.4 minus 23.8 degrees C. Okay, so just to make sure the degrees C's are gone, the grams are gone, and the only thing that survives is a joule here. Okay, so when you calculate those, you'll find out 1.51 10 to the 3 joule, also 1.51 kilojoule, if they want to call it that way. Okay, and then we are going to calculate what is a mass of LiOH, lithium hydroxide, release this amount of energy when dissolved in water. Okay, so let's understand the meaning of this. When this is a salt, lithium hydroxide, they are being dissolved. This is called the heat is being released, and this is called the heat of dissolution. Okay, And you can actually, when you're trying to do the dissolve in the sodium chloride in the water in your kitchen, if you put a lot of salt, you actually feel that water is getting a little bit warmer. Okay, so this is a heat of dissolution by putting certain amount of the salt there. So first thing to calculate is a molar mass of lithium hydroxide. I think that is because you want to the mass. Right? They want to calculate the mass, which is a practical quantity, but the useful quantity to know is actually per mole basis. So we need to calculate that. So by actually putting the lithium and the oxygen and hydrogen together, you'll find that 23.95 gram per mole lithium hydroxide. Okay, so then what was the question is this is an amount, a Q, which is 1.51. Actually, let's just use a kilojoule, okay, because kilojoule, the number was given as a kilojoule here. And then this is 23.56 kilojoule per mole. Multiply. So this is an amount that is being released by the lithium hydroxide, which is used to raise up the temperature. So this will be a positive amount to raise up the temperature of this amount. And then this will be an X mole. Right? So X number of moles of lithium hydroxide is needed to raise up the temperature of the water by this amount. Right? So this is our idea here is to raise up the temperature of this water temperatures are going up, and then that is amount of heat is needed by dissolving this many moles of the compounds. So therefore X and then the X mole of lithium hydroxide will be a 1.51 kilojoule, 23.56 kilojoule per mole. That will be a moles of hydroxide. And then I want to change that into grams. So therefore you need to multiply that by 23.95 gram 1 mole of lithium hydroxide. That will give me 1.53 grams of lithium hydroxide. Okay, so by dissolving these grams in the water of 100 grams of water, you will raise up the temperature of this much because of what is known as heat of dissolution. Okay, so this is a two experiment calculating the amount of the heat that is needed to raise up the temperature of water, and the source of the heat is actually coming from dissolving the salt to be dissolved in the water, and heat of dissolution is given as a part of the data here. Okay, thank you for your attention.